everyone, it's your math teacher, Mr. Boyden, back at it again today. Today we're starting with ratios and proportions because we're in a unit where we've now talked about dilations. We're about to move into similarity between shapes. And in order to do that, we need to make sure we have the algebra skills to be successful. So today's going to be largely algebraic. Let's get after it. Let's get our key vocab defined for the day. Okay, first thing we need to know, if we're going to be successful, is we need to know what a ratio is. It's a way of comparing two numbers by division. And maybe that sounds a little vague. Let's do an example. Maybe we said the ratio of girls to boys in the room, is 3 to 2. Okay? What does that mean? And that doesn't look like division yet. We're going to make it division in just a second. So there are 3 girls for every 2 boys in the room. That's what it means. It doesn't mean there's 3 times as many girls as 2 times as many boys. It's nothing weird like that. It's that you could break us into groups that have 3 girls and 2 boys, and you'd be able to do that, and we'd have full-size groups. Okay, that's one way to think about it. Another way to write this same thing, because ratio is comparison by division, you could write this as there are 3 halves times as many girls as boys. Okay, and wait a minute, 3 halves, maybe that's easier to think of if you think of that as 1.5. There's 1.5 times as many girls as there are boys. And that makes sense because the girls have the bigger number. It's 3 girls for every 2 boys. Okay, so that's a way of using a ratio a little bit more functionally, and you'll see them written like this as well. Okay, now let's get into proportions. Proportions are something like this. And I bet you've seen this either in your algebra class in high school or in your algebra class in middle school. Comes up all the time. It's just when you have 2 ratios, comparison of numbers by division, comparison of 2 numbers by division, so 2 division problems, or 2 fractions that are set equal to each other. Okay, that's what we have here. And so I bet what your teacher taught you is that you could cross multiply. And y'all, that's absolutely true. You can totally cross multiply these. I do want you to add something to your notes though, because as a math teacher, what I've seen year in and year out is that people automatically, when they see fractions, they immediately just show, I can cross multiply, I can cross multiply. There's a catch though. So it's only when there's an equal sign between them. Only when there is an equal sign between the fractions. Okay, so be careful. I'm going to show you 2 ways of solving this one. If you haven't had the chance to do so yet, would you please pause the video and write this one down so you're ready to go. Or, if you remember how to cross multiply, go for it, okay? So here's the cross multiply method. Okay, I'm going to call this method 1. Cross multiply says we're going to go like this, and 2 times 8 is 16, and we're going to cross like this, and 4 times x is 4x, and then we divide by 4, and we now know that x is 4. Okay? Now every year I have a couple students who look at this and say, Mr. Boyden, obviously we could look at this and we would know that. Okay? And what they'll explain to me is say, Mr. Boyden, look, 8 is twice as big as 4. So whatever number goes here must be twice as big as 2. Okay, and that's absolutely true. Okay, that's totally sound logic, and I love that people say it. And if you were thinking that, way to go. Here's the problem, though. And yeah, that is 4. But here's the problem. What if these were weird decimals and you couldn't figure out how much bigger that was? Or what if this was 2x plus 8? Uh-oh, that just got a lot harder. So what I want to do is I want to teach you techniques that'll work every single time no matter what. If you have a shortcut that you like and you want to try it sometime, totally fine by me. But I want to make sure you understand the other ways because they will always, always, always work, and we want to be able to solve any kind of problem. Okay, so that was technique number 1. There is another technique that you can use. Cross multiplying kind of takes the thinking out of it a little bit. And sometimes it makes more work for us than we needed. The other way we could think about this is remember that when we're solving, what we're trying to do is get x by itself. So ask yourself, what number is with x that I don't want to have next to x? Okay, well that number is a 2. And so that's divided. How would we cancel that out? Let's multiply by 2, do the same exact thing on both sides. And so what we get now when we do that, and I'm going to bring my work down to here, what we get now is x is already by itself. That's nice. And over here we get 2 times 8, which is 16, divided by 4. So we've only done one step, but we're already to the 16 divided by 4. and so we get x is 4. Now, for the way my brain works, I actually like doing it the second way better. And the reason I like it better is because oftentimes it ends up being less steps. It's a little bit more thinking at first to make the right strategy, but once you get the strategy right, it's very little work after that. Okay? So let's get through some examples today and see how this works. Okay, here's another one. This one, I want to solve for y. Okay, that's going to be the directions on this one. So what do we want to do? Maybe we want to cross multiply. Let's try it. Okay, and I get 5y equals, let's cross multiply the other way, 6x. But it's not magic. We still have to do some thinking. Okay, so solve for y. I want y by itself. So what's my next algebra move? What number is with y that I want to get rid of? Okay, I want to get rid of this 5 right here. So divide by 5, and then I get y equals 6x over 5. Now for some people that's a little bit less satisfying than when we had a number as the answer. But look, we only had one equation and we had 2 different variables, so we're not going to be able to get a number out of this. What we can do is solve an expression in a way that's useful. Okay, now let's try this one. This right here, if it's not clear, that's the letter Z. Okay, it might look like a 2 on the video, but that's the letter Z. I'd like you to pause the video and try it on your own. Okay, I think you can probably do this. And if you mess up, oh well, that's how you learn. Okay, so pause the video and try it. Cross multiplying, I get 20Z equals, cross multiplying, 3 times 5 is 15. We're not done yet. Divide by 20. Cancel that out. Z equals 15 over 20. Now, I don't want you to type this in a calculator, okay? Because what we're going to start trying to do as we get a little bit later in the school year, we want to start getting ready for our next year algebra class. Not only do we need some basic geometry skills to be successful, we also need to work on our algebra habits and our arithmetic habits. So I want to start doing that now. And I want to simplify this. I'll help you with it though. What we want is a number that we can divide 15 by. So 15 divided by some number and 20 divided by that same number. And we get a whole number answer when we do that. So can you think of any numbers that both of these are divisible by? How about 5? Divide by 5, divide by 5. And so let's do that. Now we get 3/4. That is our simplified solution for Z. Alright, let's try one more. Okay, if you want a head start, go ahead and pause the video and try it. If you want to work with me, then take really good notes, okay? Okay, I'm going to try cross multiplying on this one. And here's what I get when I do that. I get 8y equals 4 times y plus 3. Okay? Now, I've made a mistake on the board. I want you to try to find it. There's something that I wrote that doesn't quite match the process. Let's see if you can find that. The issue is right here. This needs to be in parentheses, because this is 4 multiplied by whatever's sitting right there. And if you don't put parentheses, then the 3 is not going to be multiplied by the 4. We're going to have to distribute this. Okay? The other thing to know is that when you cross multiply, some people end up with these 2 chunks switched. Like this whole thing is over here and 8y is all the way on the right side. It doesn't matter, okay? Equivalence is a commutative relationship. It's the same reason why 3 plus 3 equals 6 is the same thing as 6 equals 3 plus 3. Both of those statements are true, right? So if you flip everything on both sides, that's okay. Okay, not a problem at all. So if yours looks a little different, don't worry about that. It just means our steps are going to look different. They won't even be different. They're just going to look different. Okay, what I want to do right now is distribute. So I get 4y plus 12 equals 8y. Okay, let's simplify. Let's go minus 4y on both sides. And so what do I get? I get 4y equals 12. Let's divide by 4. And I get y equals 3. Okay, cool. So we've answered the question. I want to go back up and double check and see if it's right. Okay, and let's plug it in. So, is it true that 3 plus 3 over 8 equals 3 over 4? Let's rewrite and see. 3 plus 3 is 6 over 8. And that supposedly equals 3 over 4. So are those true, and how can we tell? Let's see. We could do that trick for simplifying fractions that we did just a minute ago. Okay, we're going to practice that again now. And so when I look at 6 and 8, could you name a number that both 6 and 8 are easily divisible by? How about 2? 6 divided by 2, 8 divided by 2, let's rewrite. 6 divided by 2 is 3, 8 divided by 2 is 4. I'm going to bring these down, 3, 4. And so now that is convincing to me. I have checked my answer, and I know that it's right. Okay? That's all for today. Hope you enjoy your assignment, and we'll see you next time.